All right, welcome back. This afternoon, we have two gentlemen speaking to us. We have Bob Rucker, who will speak the next hour. I will give you his longer bio during that time. We also have Jose Carlos Asprilla Galias. And I apologize if I
Godinez. Godinez.
Do what?
Godinez.
No, he told me something else, but that's okay. I'm not gonna, that's fine. I actually went over and talked to him about it.
Okay.
He is from Mexico City. He studied chemistry at the University Nacional Autónoma de Mexico and obtained a master's degree from the University Automática Metropolitana. And I apologize, I am not of the Spanish persuasion. With a thesis in separation of race mix mixtures of the chloride benstrol using narsyl chlorine, and I'm done with chemistry terms here. He is a chemistry professor and a mathematics professor. He has been a member of CMS since 2000, and he has also been a member of ISEG in Mexico City since 2010. Could you please, I'm going to let them introduce themselves. Let's give them a round of applause.
Good. Thank you. Good to have you here. So I'll get us started here, and I'll be speaking for a bit. So the title of this is Reasons to Doubt the Invisible Reweave Hypothesis, and these slides were arranged by Jose on this. Now, of course, in 1988, the shroud was carbon dated. They reported a date, I like how that's said, they reported a date of 1260 to 1390 AD with a 95% confidence limit, but in response, many people turned their backs on the shroud and accepted it as a medieval forgery. Several hypotheses were formulated in order to explain the results. The invisible reweave hypothesis by Marino and Benford is the most popular among them. The hypothesis was supported by Ray Rogers' arguments. The invisible reweave hypothesis was conceived to explain how a cloth from about 33 AD could be carbon dated to the range of 1260 to 1390. One thing in favor of this hypothesis, it allowed many people to again believe in the authenticity of the shroud. Jose says that he will try to answer Rogers and Marino Benford's arguments, and you will decide if they are correct. Now, the sequence here is number one, arguments, and we're going to maybe change the sequence a little bit. Anyway, it's listed arguments of Marino and Benford, carbon dates of the 12 subsamples, arguments by Ray Rogers, and finally conclusions. Well, I'm going to be taking some of these and just finishing up with conclusions as well. So part one, okay, arguments of Marino and Benford. Marino and Benford argued that the carbon-14 sample contained a portion of a medieval patch. You know what I noticed here? That I didn't successfully change all the slides that I wanted to, so I'm going to turn it over to Jose at this point.
Well, we'll go. Hey, can I give that? Thank you. Okay, that's our argument from Marino and Benford. Marino and Benford argued that the carbon-14 sample contained a portion of a medieval patch. They argue that after the death of Margaret of Austria in 1531, the shroud was patched in order to prevent unraveling, and the patch was so invisible that not difference when the weave was observed. They argue that the patch started at this radius area and encloses the carbon-14 sample area. The authors argue that a seam joins the patch to the shroud with a seam crossing through the middle of the carbon-14 sample area. But why did I assume this? Is this pattern observed elsewhere on the shroud? After the reweaving the herringbone weave pattern of the carbon-14 sample area, several inconsistencies are evident. After cutting the carbon-14 sample, the shroud looked like this. This is the carbon area. Okay. Areas of the raw sample and retained zone, retained part as zone 1, zone 2, and zone 3. Now, adding the carbon-14 sample shows the author's concepts for the patch. This is adding this one. In zone 1, according to the invisible reweave hypothesis, a seam joins the two fabrics, the new patch to the old shroud material. This is here we see the seam. Diagonals are observed in different directions. It is arc that a seam is running through the middle of the diagonals. This is the real weave zone. Here's now in zone 3, herringbone weave of the retained part is also observed. Supposed seam and there's a patch in the shroud. In zone 3, herringbone weave of the retained part is also observed. This seam, supposed seam. Now diagonals are observed. Here we have the supposed seam. See? Okay. Now, extending the herringbone weave from zone 1 to zone 3, the supposed seams. Adding the hypothetical carbon-14 area shows that the real herringbone weave does not match. This is proposing in the real. Does not match. Something is wrong with the batch hypothesis. But if the real carbon-14 area is added between the zones 1 and 3, it matches very well, very well. A real photograph of the carbon-14 sample area, the herringbone weave patterns at both sides do match. If there is a seam that connects the two fabrics, the new patch to the old shroud material, what would be the carbon date of a sample? For the real weave, not the one proposed by the authors, the area next to the Arizona sample would carbon as follows. The radius of the new material patch to the old material shroud is 38% to 62%. That's 0.6 centimeters to 1 centimeters, resulting in a carbon date of about 600 AD, much different than Arizona date observed. Now, if the area next to the Oxford sample on the other side is carbon dated, the sample would come from the retained part here of the shroud. The patch to the shroud radius of this area would be 32% of new material to 68% old material. That's 0.5 to 1.1 centimeters, which will be carbon dated to about 550 AD, much different than Oxford carbon date of about 1200. It is assumed that the rare sample containing a portion of the patch, piece 1 is the patch and piece 2 is the original shroud. It is assumed. There's a comment. Due to its adjacent location to the excited region and carbon-14 sample, it is highly likely that the rare sample also contained the 16th century patch. The rare sample consists of two portions. Okay. The original shroud and then the patch. It has a two-edged seam. The rare seam is a continuation of the side street seam. We can see this. The seam is running. Now, the rare sample is a continuation of the side seam. So the side strip and the rare sample is very similar. Since the rare seam is a continuation of the side stream seam, it should not be assumed that the rare sample is a patch of newer material on the old shroud material. According to Florin-Lemberg, the side strip was cut off and then reattached. So both materials are the same, the side strip and the rise sample. It is argued that the side stream and the rise seam are different because it looks darker next to the excised part. And here, the seam looks lighter here and darker here. But the seam here only appears dark because of the shadows of the folded cloth. We can see this zone is darker. It's because of the shadows here, not because it's not another seam. Now, the seam appears to be continuous through the entire length of the shroud. There's no difference. There's no. It's the same seam. Now, reconstruction of the herringbone weave. Here we see this red sample, the shroud, and the supposed patch. The authors argue that the patch had a horizontal limit at the seam without crossing it. This is what they say. Intensity line breaks at seams adjacent to the excited area and where the 16th century patch began. This is the limit here. You can see the limit here of the patch, as they say. Following their direction, the patch is next to the seam without crossing it. Now, the authors also argue that the patch had a vertical limit. You have the vertical limit here. Now, and according to the others, the patch had a limit at the middle of the herringbone weave. Oh, well, then the supposed patch should look like this. Understanding how the patch could have been done, according to them, they argue that the patch was added after the first 1531, the reinforcement with the 16th century material following the removal of the 5.5 inch and 3.5 sections may have occurred as a result of the will and testament of Margaret of Austria, who wanted to leave a portion to the shroud to her church. Margaret died around the beginning of 1531, since this would have been prior to the addition of the backing cloth in 1534. A more sophisticated patch slide repair would have been necessary to prevent unraveling on the raw edge. Now, originally the shroud looked like this, with the side strip and the 2H seam. Now, the hypothesis in 1531 to fulfill the Margaret of Austria will, a 5.5 and 3.5 inch piece was cut from the left corner. They argue this required a repair. So this area was cut according to them. According to them, the 2H seam does not belong to the patch. The 2H seam does not belong. Leaving the shroud with two missing sections, a cut like this is very unlikely. Here I have rapidly. This is the clothes must end like this. Here's the missing corner, and there another cut was done here, which is likely that the shroud could have been cut like this. They argue that the shroud was then rewoven with an invisible medieval patch. So the patch then was added with an invisible reweave. Fabric expert Florian Lemberg commented, therefore, at no time has the need to reinforce the corner parts arisen. If even the corner pieces cut away before the fire of Chambéry have not been replaced, why should remaining areas, dirty but intact, be reinforced or mended? Here's the reference. It would have been better to repair the whole missing corner, something that never was done. Now, another argument, a quasi-mosaic photograph shows a dark area next to the carbon-14 area, which is assumed to be from the patch. A patch have to appear clearly defined, which is not just diffuse. Fleury-Lemmer commented about this. The infrared pictures show a diffuse discoloration at the corner in question, a discoloration without the defined outlines of a latent G mended area. A darn would have to appear in a picture as clearly defined. It is not clear, it is diffuse. If we overlap the supposed patch onto the quasi-mosaic photo, it is clear that the dark area is bigger than the patch. So this picture does not prove the existence of a patch. Here's the supposedly patch overlap on the dark area. Also, this part of the dark area, this part of the dark area, is outside the patch area, so it cannot be concluded that the dark area is because of a patch. Fleury-Lemmer commented regarding this. These coating, obviously to the naked eye, are clearly in contrast to the surface of the rest of the shroud, but they do not have the origins in added yarns using in darning or weaving, as has been postulated. They are simply greasy dirt. This is a plausible explanation in view of the fact that innumerable unwashed hands have handled the shroud whenever it was shown in the past. The riot sample in carbon 14 area contained the same two H seam. The upper H was at 20.21 centimeters from the sizes portion, and the lower H at 0.8 centimeters. When 0.5 was trimmed away, 0.5 centimeters was trimmed away because of the frayed material. Now, the 0.5 centimeters was cut was in between the two H's, The upper H was removed, but the lower H remained. Only the lower H remained after the cutting. The carbon 14 sample show a difference in the weaving because the lower H remained, not because of invisible patch. You have different weave, but not of the patch. It's because it's the shroud and the seam, not invisible. Now the carbon 14 and rise sample are formed by two fabrics, the 2H seam and the main body of the shroud. This is why there is a difference in the weaving. There is a difference, but not from the patch, the seam and the shroud, the 2H seam. The authors argue that this difference in the weave supports the invisible reweave hypothesis, but this is not reasonable, because if the medieval patch was invisible, no difference should be detected at all. You agree with me? The authors, in support of their hypothesis, claim that people who saw the carbon 14 samples detected a different weave. There's a different weave. But there's an inconsistent reason. There would be no visible difference in the weave due to an invisible reweave. The carbon 14 samples were rewoven is indicated because people can see difference in the weave. Now, I want to see this comment quoted by the authors. Adler says, you have no way of knowing if the area you took the carbon 14 sample from represent the whole cloth. That's an area which has obviously been repaired. There's cloth missing there. It's been rewoven on the edge. Edge is very important, on the edge. They even cut part of it off because it was obviously rewoven on the edge and edge. The simplest explanation why the days may be off is that it is rewoven there. Okay, Adler did observe a difference weave on the edge, the remaining lower seam, but not the patch, not the basket. This is a difference, but not from the patch. The supposed Suppose invisible seam is not located on the edge. It's in the middle, not on the edge. Another comment. A binary analysis of the photograph of the Zurich carbon-14 by Thomas Ferguson, resulted in their perception that the sample was touched up to prevent unraveling. They further observed, we have no to say that we see the field pattern clearly on both sides, but there is still something different left versus right. Here, if Ferguson saw a difference in the weaving, it was not the invisible patch. Something different left versus right. Left, there's a difference, but not the patch. And another comment. David Peterson, owner of the phrase Taylor, immediately recognized the disparate weave pattern and difference in thread size, stating, there is no question that there is a different material on each side. It's definitely a patch. He is observing a different weave, the seam and the shroud, but not the invisible patch. There is a difference because of the seam and the shroud, not the invisible patch. Now, let's move to another argument from the authors. The statistical arguments. The authors argue that the statistical analysis done to the carbon-14 samples supports the medieval patch hypothesis, whilst a statistical analysis concluded that the carbon-14 samples were heterogeneous between labs. In the same time, the samples were homogeneous within each lab, intralabs. Each lab received homogeneous samples. Walsh concluded that the carbon-14 samples were heterogeneous between labs. The mean carbon-14 to carbon-14 radius were different between labs, each lab received a different amount of carbon-14. If there were a mixture of a patch in the shroud, the carbon-14 samples would have been heterogeneous within each lab, intralab. It's very heterogeneous, but that's not the case. This heterogeneity between the labs led the authors to argue that for the presence of a patch, but if there were a patch shroud mix, the analysis would have detected the heterogeneity within each lab, contradicting Walsh's results. In fact, this statistical analysis is against the patch hypothesis because each lab produces subsamples with carbon-14 to carbon-12 radius that were homogeneous. Now, the inter-lab heterogeneity made it possible to plot the carbon date of the samples as a function of the distance from the shorted edge of the shroud. The authors also argue that the angle of the straight line is equal to the angle of the invisible bending. This angle and this angle, the angle of the straight line looks like the same. There's an argument, looks the same. But it is not true because the angle, not the slope, depends on the separation of the data along the x-axis. Here, 3 different angles can be produced with the same data, modifying just the separation on the x and y-axis. The same data, different angles. Is that okay? You can? Part 2. The 3 labs cut their samples into 12 total subsamples. Oxford received 3 subsamples, Zurich 5, and Arizona 4 subsamples. How the subsamples?
Yeah, maybe I could talk through this a little bit. So the 3 labs cut their samples into 12 total subsamples. Oxford, Zurich, and Arizona cut them into 3, 5, and 4 different subsamples. But how the subsamples were cut is not known, but there are 3 possibilities: vertical, horizontal, or a mixture of both. So the invisible reweave hypothesis was originally communicated with a 50-50 mix of new material, about 1520, 1530, 1540, somewhere in there, and old material, about 30 to 33 AD. So that if we just go with a 50-50 mix here, the old material would be yellow at the bottom, the new material would be the orange at the top. And if all the cuts were vertical, then it would look like this, with Oxford, 3 cuts, 3 different subsamples, Zurich 5 and Tucson 4. So for a 50-50 mix of new and old material, vertical cuts result in every subsample being carbon dated to about 810 AD. This contradicts the mean carbon date of 1260. But if the cuts were horizontal, it produced many subsamples that would carbon date to the range of 1520 and 33 AD. This contradicts the measured range of 1155 to 1359, so that when you consider the individual dates of the 12 different subsamples, you run into problems with the invisible reweave. With a 50-50 mix of new to old material, neither vertical nor horizontal cuts produce carbon dates consistent with the 12 subsamples measured dates of 1155 to 1359. Now, in my analysis, if the mean date is forced to be 1260 AD, with a slope being a function of the distance from the short end of the cloth, with a gradient of about 36 years per centimeter, 91 years per inch, then the cloth must be about 81.2% new material, if I assumed 1520, and 18.8% old material, if we assume 33 AD. So it would look like this, with a bit of a slope between the new and the old material. Again, the yellow at the bottom is the old material from 33 AD. The orange is the new material from 1520, I'm assuming. So if all the cuts were vertical, then the mean date of 1260 and the gradient of 36 years per centimeter would be satisfied because of the new to old mix. But if all the cuts were horizontal, then the subsample carbon dates would be either 1520 AD or earlier than the measured range of 1155 to 1359 AD. If each cut had equal probability, each lab, they wouldn't know, they wouldn't care how they were cut into the subsamples. So then the probability of all the cuts being vertical would be only 0.2%. That would be 0.5 to the 9th or 10th power. So there would be a 99.8% probability of there being some horizontal cuts. This would cause some of the subsample carbon dates to contradict the measured range of the 1155 AD to 1359 measured values. Thus, this 81.2 to 18.8 mix would with a properly sloped interface, is very unlikely to be consistent with the 12 measured dates, only a 0.2% probability. If the subsamples were probably cut using a mixture of vertical and horizontal cuts in the example below, which I will actually talk about in the next presentation. Even if an 81.2% to 18.2% mix is assumed, none of the subsamples would date within the measured range of 1155 to 1359. And so that in my results that I'll show next time, next session, but the neutron absorption hypothesis predicts carbon dates in red based on calculated neutron distributions in the tomb. These calculated dates are consistent with the measured dates in black without assuming an invisible reweave. So the invisible reweave is totally unnecessary.
Okay. Thank you. Now we're going to move to another arguments by Ray Rogers. I hope you have a little background in chemistry. Okay, Ray Rogers claimed he obtained samples from the rest area next to the carbon-14 area. He said he observed in microscope a gelatinous substance around the threads. He argued that the threads were coated with alizarin dye of Arabic gum that was used to match the color of the main body of the shroud. His conclusion was this: the radiocarbon-14 samples contain portion of a medieval patch. To support his arguments, he presented two pyrolysis low temperature mass spectra. The rise sample, according to him, is the patch, and the back angle zone is the shroud. He's trying to support the patch in the shroud. Rogers argued that the rise spectrum is the key evidence of this gelatinous coating because it proves that some pentose sugars were present. In his word, he said, "This proves that the sample contains some pentose sugar units. This is unique among all of the shroud samples. No other area showed this pentose signal. Cellulose decomposes much more slowly than a plant gum that is composed of pentose units. The cellulose of the sample had not started to pyrolyze." This is very important because he's saying that the sample had not yet started to pyrolyze. But let's see if it was. He saw on this rise spectrum, he said that this is from the patch, a moderate 96 signal coming from furfural and a very low 126 signal from hydroxymethyl furfural. He concluded after observing this spectrum, the arabinose, the coating, he's talking about the coating of the threads, the pentose sugars were detected. So he concluded that this is the right sample were part of the patch. Pentoses do not produce any hydroxymethyl furfural. His argument is this: pentoses suffer the pyrolysis producing furfural, which is a 96 signal, but no hydroxymethyl furfural signal. That's why we can see there's no signal here. That's what he says. Now, in a second spectra, well, the back ankle spectrum, he said this is from the shroud. The former one is from the patch, and this is from the shroud, according to him. There is a low 96 signal and moderate 126 signals from hydroxymethyl furfural, concluding that there is no pentoses. So, in the example, only exoses. According to him, the rest, this spectrum was coated. The thread that was not coated here, but in the right sample they were. Rogers' argument, exoses 6 carbons, the cellulose, the thread, produce hydroxymethyl furfural. That's what the 126 signals, and also furfural, 96 signal. Rogers argued that the back ankle, the threads were not coated, but the rise sample threads were. He concluded that the rise sample belongs to the patch and the 1EV, the back ankle zone, belongs to the shroud. But does the rise spectrum prove that the threads were really coated? Was Rogers right? Rogers assumed that arabinose, he's talking about the coating, Arabic gum, decomposed at low temperature. This is very important. He's saying that low temperature, it could be under 100 degrees Celsius. But according to the Iran, the Sonodis investigator, this is not true. The arabinose hardly changed before 200 degrees Celsius. The pyrolysis of arabinoses could be mainly divided in 3 stages. The first pyrolysis stage starts at 200 degrees Celsius, and the weight loss rate increases slowly. The first peak's weight loss appears at 253, different than Rogers, which say that the coating begins to degrade at 100%. Arabinose starts pyrolysis at 253 and not at a low temperature. It is unlikely that the rise low temperature spectrum recorded under 100 degrees Celsius proved that arabinoses, pentose sugars, suffer pyrolysis. Also claimed that arabinose activation energy, is 19 kilocalories. Bedura showed that arabinose activation energy is 42. That's different. Roy said that the activation energy is 19, and Duran is saying that 42 kilocalories. It is higher than reported by Reuters. Thus, it is not correct to conclude that arabinose easily degrades as Royer is assuming. I can present some reaction to show that arabinose is not decomposed as easily as Royer is assuming. Another argument by Reuters: it is true that the rice threads remain unaltered and only the coating suffers pyrolysis. That's what he said when he said the rice sample. What does this rice spectrum show? In Duran's study, cellulose, the threads, undergo pyrolysis through two molecules, levoglucosan and levoglucosanone. The presence of these two molecules confers the degradation of cellulose. Can we detect these molecules in the rice sample? If so, we can be sure that degradation of the threads were done. Here we present the cellulose suffer oxidation in obtaining this levoglucosan compound and then dehydration producing levoglucosanone at temperatures of 300 degrees. 300 degrees is much higher than Royer says under 100 degrees Celsius. These molecules suffer fragmentation when entering the inlet of the mass spectrometer. Pentoses arabinose does not produce these compounds. Only exoses, only the threads produces these compounds. Levoglucosans, when entering the inlet of the mass spectrometer, suffer fragmentation. These molecules entering the mass spectrometer breaks down, producing several fragments, which are, according to Cato, this 60 signal is derived, among others, from levoglucosan, which has major electron impact fragments at masses 60, 73. These fragments are produced by the threads. When the sample came into the mass spectrometer, the electron impact produced fragmentation, breaking the molecule. Thus, we have these fragments: 55, 57, 60, 70, 73, 144. These fragments are detected at the rice sample. So we conclude that the rice samples really suffer oxidation against Royer's argument. He said that the threads remain unaltered, but according to this, the threads really suffer oxidation. Now, levoglucosan is also suffer fragmentation. According to Cato, additionally, 68 is attributed mainly to levoglucosan with electron impacts fragments. This is 39, 68, 53, 96, and 42. There is no doubt that the sample really suffered dehydration. This is against Royer's argument, which says that the threads remain altered and only the coating suffer pyrolysis. This is again his arguments. It is concluded that the rice samples really suffer oxidation and dehydration, contrary to Royer's argument. Thus, Royer's conclusion that the threads did not suffer pyrolysis, so remain unaltered and is untenable. And the argument that they were coated with an Arabic gum is not completely true. You want to come to the conclusion? There's something that's more. You can skip the conclusion.
Okay. It is concluded that the race sample really suffered oxidation and dehydration, contrary to Rogers' argument. Thus, Rogers' conclusion that the race threads did not suffer pyrolysis, so remained unaltered, is untenable. With the argument that they were coated with the anaerobic gum is also not completely true. That's what you said, I think. So, according to Rogers, it goes on here?
Because of time.
Yeah, just because of time. Okay, we're going to skip forward a little bit here.
You still have
You have 5 minutes to talk. Any questions? 5 minutes after.
Okay, so the three former spectra in all the same moderate 96 signal had a very low 126 signal. If we follow Rogers' reasoning, these spectra should prove the existence of pentosis. But this is not true. There is no pentosis at all. So a moderate 96 signal and a very low 126 signal does not prove the presence of pentosis. For me, I had chemistry, but I don't understand what this means, okay? University of Michigan, I took chemistry, 101, but that was a long time ago, and it wasn't organic chemistry either. So, wow. So let's just skip forward here. Stirp's conclusion, this has led to speculation of a common causative agent suggesting that the linen cellulose had suffered thermal degradation and the image fibrils were simply more oxidized and dehydrated than the non-image ones, but less oxidized and dehydrated than the scorch fibers. That was part of the argument that's going on here. But, wow, very interesting. A lot of organic chemistry here, wow. So I'll just, let me mention one thing here. Should we go over the, okay, you're going to give me the flexibility. The presence of this 131 signal in the race and back ankle spectra confirms that both samples belong to the same fabric and not the patch, and not from a patch on the same shrouds. So it essentially invalidates the invisible reweave. Now, there have been several attempts to explain this 131 signal. Rogers said it is an amino acid, a 131 hydroproline, but the samples are not from a blood area. Latendresse had two other options. Number 3, Beta et al. Claimed it to be an alkene from the many candles burned from the shroud. But there's another possibility that Jose points out here. Possible effects of Jesus' resurrection and what a strange, unique event that would be. There are 6 types of quarks called up, down, charm, strange, top, and bottom. Those are the names of the quarks. They're just names. They don't mean anything in particular. Normal matter is made up entirely of up and down quarks. That's what protons and neutrons are made of. Up and down quarks, but there's 4 other types of quarks, with each proton composed of 2 up quarks and 1 down quark, and each neutron composed of 1 up quark and 2 down quarks. I like this stuff. Possible effects of Jesus' resurrection. Theoretically, a more stable form of matter would contain an equal number of up, down, and strange quarks, and not the nature of matter that we currently have. But the more stable is with an equal number of up, down, and strange quarks. This form of matter is called strange matter. But for normal matter to change from strange matter, it must overcome a significant energy threshold. So perhaps a burst of energy during Jesus' resurrection could have overcome this energy threshold to change some normal matter into strange matter, consisting of strange quarks, consisting of what they call strangelets. Such an energy burst is also proposed to explain the fission of deuterium nuclei in my vertically collimated radiation burst. Let's talk about that later, okay? Okay, so could strangelets explain the 131 signal? Since strange quarks are heavier than up or down quarks, a possible explanation of this 131 signal is a 5 atomic mass unit, AMU, hydrogen strangelet produced in Jesus' resurrection, which were captured by the 126 HMF in the fibers. This would have increased its molecular weight from 126 to 131, which caused the 131 signal in the spectra. This is similar to neutrons absorbed in nitrogen-14 to produce new carbon-14 that shifted the carbon date from about 33 to the range of 1260 to 1390, as shown in my previous diagram. According to my hypothesis, neutrons emitted from the body would cause a distribution of carbon date that would peak over the center of the body mass, about 8,500 AD. We have a reference to that Jose has written, the possible existence of strange quark matter particles in the Turin shroud. These strange quark particles are taken seriously by many different researchers, and they search for them in very odd places around the world, at the bottom of the ocean, in meteorites, etc., etc. They're looking for them because they ought to be more stable than our form of matter, but they haven't found them yet. Maybe they're on the Shroud of Turin. Isn't that interesting? So the conclusions, the race spectrum does not show evidence that the threads were coated with an Arabic gum, arabinos, that starts degradation at 253 centigrade. Linen threads were not dyed with alizarin. The weave in and around the carbon-14 sample show no evidence of an invisible patch. Neither the shroud nor the race sample contain a medieval patch. The carbon dating of the subsamples is not consistent with the patch hypothesis. The race and back ankle samples were already oxidized and dehydrated before entering the mass spectrometer because of the image imprinting process and the aging of the cloth. And the 131 signal on the shroud at both sample locations confirmed they belong to the same fabric, contrary to the invisible reweave hypothesis. There have been multiple attempts to explain how the 1988 carbon dating of the Shroud of Turin to 1260 to 1390 could be consistent with the shroud being the authentic burial cloth of Jesus. But most of these have been rejected after sufficient consideration. It should now be clear that the invisible reweave hypothesis should also be rejected because there is no convincing evidence that it is true and is very unlikely to explain the 1988 carbon dates of the 12 subsamples and cannot explain the carbon date of the Sudarium of Oviedo. Fortunately, the neutron absorption hypothesis, which is part of the vertically collimated radiation burst hypothesis to explain image formation on the shroud, offers an explanation for not only, one, the mean carbon date of 1260 to 1390, but also explains, two, why the carbon date is a function of the distance from the short end of the cloth, three, the range and distribution of the 12 subsamples that were dated in 1988, and four, the carbon date of the Sudarium of Oviedo, which is believed to be Jesus' face cloth to about 700 AD. The invisible reweave was an attempt to explain away the mean carbon date of 1260 to 1390, but it offered no evidence that the shroud was the authentic burial cloth of Jesus in and of itself, or that the image was due to his resurrection, since such a reweave could have been made on any piece of cloth. However, the neutron absorption hypothesis, since it is based on a burst of neutrons emitted from the dead body of the man that was wrapped in the shroud, can only be explained by it being Jesus' dead body that emitted neutrons in his resurrection. Thus, the carbon dating of the shroud becomes one of the strongest arguments in favor of the authenticity of the shroud and the truth of Jesus' resurrection. This helps us realize that the most important result of scientific research on the shroud is the dedication of our hearts to the one whose image is on the shroud, the creator of the universe, our Lord Jesus Christ.
Amen.
Thank you.
Questions? I'm going to do something unusual and will come from me. So you showed two mass spec data where there was a 96 spike in both of them. I think you're telling us that those two are different samples sent to different labs?
That's what Royer says. They're different, but
But But they both had the 96 molecular weight in
Yes.
both of them?
But the height of the 96 signal is different on the right sample
Right.
than the back angle. So he concluded that the right sample is from the patch and the other one is from the shroud. But that's not real because we skipped another spectra that showed the same 96 to 126 profile, and which is made of cellulose that contradicts the Roy's conclusion.
Thank you, I appreciate that. Other questions?
So to add further credibility to the doubts about the reweave hypothesis, Dr. Jackson showed the transmitted light photographs from 1978 before the carbon-14 dating sample was taken, and the horizontal banding that goes across the width of the shroud continued into that area. And he's saying if that was a reweave, we would see disruption there and no banding, but there is banding there.
Yes, John Jackson has said it's absolutely certain that the invisible reweave is not true, based on that evidence. When I met with him, I think it was 7 years ago. On my paper 33, I think starting on page 15, I give my 9 reasons for rejecting the invisible reweave, and that is one of the reasons.
Thank you.
How do we find your paper?
I'm sorry?
How do we find your paper?
Shroudresearch.net. My paper 33 is on carbon dating. So that's so yeah. So go over to the 3rd page on shroudresearch.net. 3rd page over is all my papers. Paper 33 is on carbon dating. So page 15, starting at the bottom.
All right, let's give him a final hand, please. And anybody against Ohio State, I'm good with this. Thank you, guys.
Okay.
Great job.
Yes. Well, I'm going to just stay connected here.
There you go. That'll work good.
Yes.
Thank you.
Are you chemist?
I am. I was in a previous life. Stopped doing it in 2020 because I lost my legs. I just couldn't stand my legs on this. But yeah, absolutely. Your presentation completely fascinating.
How can I get out?
Oh, you want me to take that off? Sure. No problem. Yeah, you're stuck forever. I'm gonna let you take it out of the bag. Oh, I just didn't want to get personal there. I got it. Thank you guys again.
Where should I set up some giveaways here?
Oh, you could put it on the table. That'll work good. And your mic? No. Thank you.
Thank you so much.
And you're mic'd, right? Yes. You're good to go.
I don't know if they're going to work on it.
So we will get started in about 5 minutes.
I'm short of saying.
They're all being filed. We have to have this last week. I'm sorry I missed this one too. Is this English? Well, I wanted to hear from you. I just wanted to. That's why I was. She made the effort even to. That's why I went. I hope it's
Think about how long that has
and there's three.
Well, I did. I did it 11 years ago. I did it here 11 years ago. And it's
2014. Say the same.
Part of why in the argument about to smooth it out so you don't see that.
I just got
You know, that
I got licked. But, so, many times, I just use some examples. And so, I enjoyed it. And then I and for the Israel,
because we were in Texas, and I thought, and Missouri, I thought we were the same, which I think it is.